Hello and welcome back. This is time for 10.7, Factoring Special Products. In this lesson we're going to look at a couple of unique situations and how we can factor different quadratic expressions and use maybe some shortcuts to try to get to those answers maybe a little bit faster than just doing traditional kind of guess and check approaches to factoring. Today we're going to take a look at how to do difference of perfect squares in this example. And here's a little bit of an algebraic expression that kind of helps us understand exactly what this may look like and how to use it. So with difference of perfect squares, you're going to get an expression like a squared, or this says a squared minus b squared equals a plus b times a minus b. Okay, that doesn't mean a whole lot to you, but the idea is that the first term is a perfect square, the second term is a perfect square. It's a subtraction problem, and when you factor it out, you're going to get, you'll kind of take the square roots of this part and the square roots of this part, and get an a plus b times an a minus b. Okay, so I said that. Now let me show you how this may actually work and by solving this particular problem. Here's x squared minus 49 equals 0. We need to solve this equation and find values for x that make this true. Well, this is a unique quadratic expression. There's no middle term. There's no bx in the middle. It's just x squared minus 49. That's our hint. This is something different. Well, ask yourself, is this a difference of perfect squares? Is this a perfect square? Is x squared a perfect square? What's the square root of x squared? It's x. It is. What's the square root of 49? 7. So that's a perfect square too. So this fits the pattern. And so once you know the pattern, this is going to allow you then to quickly factor this and make it look like x plus 7 times x minus 7. And we'll have this equal 0. X is the square root of x squared, 7 is the square root of 49. So those are the two square roots, x plus 7, x minus 7. You can always fit that pattern. Since this is asking us to solve for the equation, we're going to set each of these parentheses equal to 0 and have x plus 7 equaling 0, and we would do x minus 7 equaling 0, and then you would solve each of those little mini equations. This x would have a value of negative 7, and this one over here would have a value of x equaling positive 7. So negative 7, positive 7 are the two values that can go into this equation to make it true. Okay? So that one works pretty good. Let's take a look at this one over here. I have 16x squared minus 64 equals 0. Again, don't have a middle term, don't have that bx, just two terms, so that tells you that something different is going on here. Ask yourself, is this a perfect square? Well, square root of 16 is 4, square root of 64 is 8. Yes, this is a difference of perfect squares. It fits the pattern. So we're going to factor it using kind of this idea that the square root of one plus the square root of the other times the square root of the first one minus the square root of the second one is the solution. Okay? So square root of 16 is 4, and square root of x squared is x, plus the square root of 64, which is 8. That's my first binomial, and we're going to multiply it by that same expression, just with a minus sign in the middle, so 4x minus 8. You can FOIL this out and check to see if it works, but it does. Alright, so I have 4x plus 8 times 4x minus 8 equals 0. Take each of these equations again, set them equal to 0, so we can solve for the missing value, and then you've completed the problem. So 4x minus 8 here would equal 0, and I'm just going to kind of do this in my head. I'm going to subtract 8 and divide by 4. This x would have a value of negative 2, and over here, after I add 8 to this side and divide it by 4, x is going to have a value of positive 2. So we solve both these equations using the idea of difference of perfect squares. Hope that helps. Try a few out, and we'll talk about this soon.